Hello, mentors. Welcome to San Lorenzo. So this is shop number 3 in our gelato tour. So San Lorenzo rules are the following. We have 5 flavors: vanilla, strawberry, chocolate, pistachio, blueberry. 2 scoops always, and you can repeat the flavors. That's okay. No syrup or salsa, and actually cone only is just simpler, according to San Lorenzo. So the questions are, how many gelatos are there? What if we had 1,000 flavors? And then the secret menu. Here are examples. This would be Choco Square, Choco Choco. And then these two are really the same. Pistachio on top and strawberry on the bottom, or the other way around. So you could call it Peaceberry or Prestaccio. Doesn't really matter. It's the same gelato. So again, students would first make a line, and some students could be the clerks and just order. I could order vanilla, for example. These would be my gelato. Or I could do a chocolate pistachio, for example. And then I would pay and eat my ice cream. So at this point, you could use the manipulative, but it's also good to abstract and at some point say, hey, let's just not use the cones because that doesn't give us information. We know it's always cones. There's no cups in this gelateria. So this is enough to determine which ice cream or gelato you're talking about, right? So how many? Again, similar to in the first Gelateria Prima, the students could make a table to visualize the 2 scoops. It'd be something like this for the first scoop. And then the second scoop, although it's kind of dangerous to say it's the second because the order doesn't matter. But anyways, the other scoop would be like this. And then they can see immediately that just a table arises. Let's create it. And during the meeting, you could actually, of course, draw it in your small whiteboards or have everyone draw it. So what we're saying is that we have sort of 25 options, but do we really have 25 options? And so here's where the combinatorial discussion begins. First, do we have all ice cream choices in this table? I guess we do, because we don't need to think about cone or cup, and there's no more flavors. But then what ends up happening is that these two, for example, chocolate and vanilla, this would be the gelato with chocolate and vanilla, is the same as this option, chocolate and vanilla. So you have to think that these two are really the same. So you're just counting these once. Now the diagonal is counted exactly once. These are just for the people that really love or prefer one flavor and just has both scoops of that same flavor. Let's just mark it with an X for now. So those are legitimately 5 choices. But what students will realize is that, okay, above this diagonal, we have choices of 2 different flavors, but they're mirrored, they're exactly repeated if you flip it in the lower part. So we would be lying if we count this, the whole thing. We just have to count Y. So we would just delete one heart here, so to speak, and just keep one. Same for example, this here. This would be chocolate and blueberry, right? But chocolate and blueberry is the same as blueberry and chocolate. It's just a mirror. So we really end up deleting this. And so what happens is that we only need to really work with one part of the diagonal. That represents all choices for different flavors. So you want your students to understand this, that the diagonal counts, you don't remove it. They're choices, and there's 5, one for each flavor. And then that out of these two parts, the upper and the lower, you have to just stay with one of them because that represents all choices. The order doesn't matter, right? And you could make lots of examples with the manipulatives. Now, interesting second part is how to count this without doing one by one. There are several ways. Students could say it's half of the table. Well, almost, because the diagonal counts. So, okay, removing the diagonal, you would have 20 elements. So half of them would be 10. So that's a nice way to say that we have 10 above. And then 10 plus 5 is 25. Another way would be 1 plus 2 plus 3 plus 4 plus 5. Some people may know that as a triangular sum and use that result. It's really important to now extend to one more flavor. And let's just do it right now. So that's going to be the extension, part of the after the secret menu. You would, let's do it. End up with one more flavor. Oh, sorry. Let's try to capture here, more or less. Yep. So this would be one more flavor. Let's just create it real quick. Let's say we have some black, interesting, maybe Oreo flavor or something that we put here. And just this table, just this representation, it's really easy to see that what we end up doing is just this. Let me put plus here. We're just extending this. So for each, this new flavor just combines with the old ones just once because of the right of the order, just once. And it also combines with itself because one person could order Oreo with Oreo, 2 scoops of Oreo. So you just have to add 6 for the new ones. And then each time you add one more. So you get this triangular sum, 1 plus 2 plus 3 plus 4 plus 5. And that's the combinatorial pattern for this gelateria when you add one new flavor. Let's quickly talk about the secret menu. So we're in San Lorenzo. Remember, the first secret menu for Prima was done by mentors. In Rome, there were 2 rounds. Same scoop 0, flavor and paleta for one pair of students to be the clerks. And the second round, scoop is strawberry and not cup for the other students. Now, what's really interesting here in San Lorenzo is that we will not tell the students what's the rule. They will actually brainstorm it, but helped by the mentors. So they get just 30 seconds, 1 minute or so, just one mentor with the 2 students. The 2 students try to come up with a rule, and the mentor checks that the rule is well defined, it's not so simple or not so complicated. Here are some examples, both being chocolate, that would be just one option, so not too interesting. Repeating flavors, that'll be 5 options. As we say, this would be the diagonal here. Repeating flavors. Other options could say at least 1 chocolate, no chocolate, and no strawberry, things like that. So these rules are kind of simple because you don't have much other choice. You don't have syrup and you don't have paleta or cups or anything like that because you just have cones. So you just have to talk about the flavors here. The other student would play detective. So that's interesting. Another extension, but you don't have to do it because it's just going to be the next gelateria is what happens if we add one more scoop. But naturally, students may ask that, and you would say, oh, let's wait till we get to the other gelateria. So it's a natural continuation to this problem. Finally, let's do this part. So when considering this table, that's what we were trying to try to think about. How many gelatos are if we had 1,000 flavors? So again, students would imagine making a table that's really big. Of course, impossible to do during the meeting. but you could draw it, you could sketch it, and just have your imagination help you. Let's assume this is so we say 1,000. Wow, so yeah, it's really big, 1,000 by 1,000 table, right? And then students could reason, look, the diagonal represents all the people, right? All the gelatos preferred by people that really like one particular flavor. If you remove that, that's how many entries. So that's going to be 1,000 entries. Then you take half because all the copies here live here because of the order of this symmetry. So you generalize. I mean, you're still in 1,000. You're not in n, right? Which of course you could also do, but you don't need to. But you're now at a point where you're working with a really big number, still concrete, but really big. So you have to think generally, in general terms. You cannot count or use other resources. So this forces you to use general thinking. That's why we put this exercise. It's not because of the complication of the formula, but because it forces you to think more algebraically and reason. Yeah, so you would deduce or derive an expression such as you have to do this minus the diagonal, then divide that by 2, and then add the diagonal again. So that's going to be the answer for the number of the. It's kind of similar to some things that are here. Yeah, well, actually, this is not in that way, but in other, you'll see it a little more here when you go to the other one. Anyways, so that's San Lorenzo. I hope you really enjoyed that gelateria and see you in the next video. Goodbye.